Hello everyone, this is a video on quantum mechanics where we'll be solving numericals from scattering chapter. So this will help you in your entrance exams. So the chapter is quantum scattering. This is solving numericals. I will give you some concepts. So first of all, the scattering cross section. Scattering cross section. Uh, First thing is let n be the number of incident particles crossing unit normal area. Suppose this is a normal area, so n number of particles are crossing through it. Okay, and there is a solid angle d omega. Solid angle d omega in the direction this one, and theta is the angle of scattering. Theta is the angle of scattering. So differential scattering cross section formula: differential scattering cross section. Scattering cross section is what? Sigma of theta phi. Sigma is a function of theta and phi is equal to n by d omega by capital N. Okay, and the total scattering cross section. Don't worry, if we do numericals, you will understand. Total scattering cross section sigma is equal to integration sigma theta phi d omega. Okay, so d omega is actually sine theta d theta d phi. So we'll write it here. We'll substitute it here. Sigma theta phi sine theta d theta or d phi integration 0 to 2 pi and integration 0 to pi. So this 0 to 2 pi is the limit of d phi and 0 to pi is the limit of d theta. Okay, all right. Mm, okay, let's do a numerical. From there, you can understand what I'm trying to say. The first question in this. First question. Uh, okay, we'll start with the derivation from the just a second. Mm, right on in the theory. We'll start with the derivation slowly and then we'll move to numericals. In the theory of scattering, by fixed potential, by fixed potential, the asymptotic form, the asymptotic form of the wave function is psi tends to a e to the power ikz plus f of theta phi e to the power ikr divided by r. Okay, so the question is obtain the formula for scattering cross section obtain the formula for scattering cross section in terms of the scattering amplitude, in terms of the scattering amplitude, in terms of the scattering amplitude f of theta phi. Okay, so this is the question. Wave function is given. This is the wave function, and you have to form like obtain a formula for scattering cross section in terms of the scattering amplitude f of theta phi. Okay, so how to do it? Okay, let's see the solution. First of all, what is scattering cross section? Scattering cross section is you simply sigma of theta phi, right? If the potential is symmetrically, if the potential, write it down. If the potential is, what did I say? If it is a spherically symmetric potential, if it is a spherically symmetric, if it is a spherically symmetric potential, then this sigma theta phi becomes a sigma of theta. There is no phi in it. Okay, and yeah. So let's move to the question. We have to find this. Okay, we have to find this sigma theta. Then we are asked here scattering cross section, scattering amplitude. Okay, scattering cross section in terms of scattering amplitude f of theta. This is f of theta phi is called your scattering amplitude. Okay, and your sigma theta is your scattering cross section. Okay, your d sigma by d omega. This is called your differential scattering cross section. So these are the terms that you need to remember. Differential cross section or scattering cross section. Okay, and if I integrate this differential cross section, okay, like this, I will get sigma, right? So d omega cancel out, and in place of d omega, I can put what, sine theta, d theta, d phi, integration 0 to 2 pi, 0 to pi, any order you can take, because from d omega I can put here. See, d omega is sine theta, d phi, so I can put it here. So you will get sigma is equal to 0 to 2 pi, 0 to pi, d sigma by d omega sine theta, d theta, d omega, d phi. Alright. Okay. So let's find the solution. The question is we have to find scattering cross section. That means we have to find this sigma. Okay. So how will you find the sigma here? See, first of all, uh, write another formula for sigma. Sigma theta is equal to probability current density. This type of question won't come, but for understanding the concepts, we have to do it. Probability current density. From this one question, a lot of concept will be clear of the scattered wave. Probability current density of the scattered wave per unit solid angle, per unit solid angle divided by probability current density divided by probability current density of the incident wave, of the incident wave. Okay, probability current density is the scattered wave per unit solid angle divided by probability current density of the incident wave. Okay, so let's find it out. Okay, first of all, probability current density is what? It's J. Okay, JRT. This is the probability current density. It is a vector quantity. Okay, JRT. Okay, what is the formula for JRT? Its formula is IH cut by 2m. Here we will write it as 2 mu. Okay, psi del psi star minus psi star del psi. If you remember, this is the formula for probability current density J. Okay, JRT, like if it is calculated with the given wave function, we get interference terms, okay, between the incident and scattered waves. Uh, but in the experimental arrangements, these they don't appear. So we calculate the incident and scattered probability current density, that is a Ji. This is incident current probability current density, and Js, that is scattered uh, probability current density. This is incident probability current density. All right. Yeah. So we have to calculate them separately. All right. So first I will calculate incident probability current density. So that is Ji. Okay. Ji is incident current probability density. So this is a I h cut by 2 mu. Okay. And the formula is the amplitude square into minus ik minus amplitude square minus ik. So that will give me what? If you see I h cut divided by 2 mu, okay, minus, um, sorry, this is plus, yeah, plus. So that will give me minus 2a square ik. Okay, I have to multiply this here. So I will get as II is minus 1 is plus 1. H cut a square, h cut k a square divided by mu. So this will be the final expression for Ji. Okay, this is the final expression for Ji. So where is this minus ik coming from? It's coming from this wave that is given here. What is the wave given? E to the power ikz plus this is so ikz. This is, so from here we can see this is the incident term. Okay. Yeah. All right. Yeah. So what is the this is the incident current density. We got this one. Next is the what? Next is your scattered probability current density. Scattered probability. You have to study this chapter very thoroughly to solve these questions. Otherwise, you won't be able to solve. This type of questions won't come in your GATE exam, but just to like they may help you in interviews. Okay. So scattered probability current density. So this is your JS. JS. What is JS? This is IH cut by 2 mu. IH cut by 2 mu. A square f of theta phi square. Okay. Alright. Yeah. Okay. And inside it will be minus IK by R square minus 1 by RQ minus IK by R square. Okay. Plus 1 by RQ. So here 1 by RQ, 1 by RQ cancelled out. So this will be removed. So IH cut by 2 mu a square f of theta phi whole square, and this is a minus 2ik by r square. Okay, so 2 to get cancelled out, I is minus 1 plus 1. So what will I get? I will get the expression here, h cut k by mu a square f of theta phi square. Okay, and 1 by r square here also. So this is the expression for Js probability scattered probability current density. Okay. Yeah. All right. Okay. So the cross section, scattering cross section, we need to find. So what will be this one? So that will be what? See, sigma theta. I have written the formula. I will write it again. Sigma theta probability current density. Probability current density of the scattered wave. The scattered wave per unit solid angle. For unit solid angle divided by probability current density of the incident wave. Okay, so let's see. So this is the probability current density of the scattered wave. So h cut k divided by mu a square. Okay, and f of theta phi whole square. Okay, see one thing. When I'm writing per unit solid angle, so if I take this to this side, that will be actually per unit solid angle Js divided by 1 by r square. So this will be in the right side. So this is called your per unit solid angle. Okay, because 1 by r square is the solid angle subtracted by unit area of the detector. Okay, just remember this. 1 by r square, you can write it here. 1 by r square. 1 by r square is the, this is the solid angle subtended. So solid angle subtended by unit area of detector at the scattering center, scattering center. Okay, so this is your probability current density scattered wave divided by what is the probability current density of the incident wave. We have calculated it, that is h cut k a square by mu. So h cut k a square divided by mu, correct? Yeah. Yeah. So let's see what things can be cancelled out. This cancel out. A square is to cancel. So this is equal to what? F of theta phi whole square. So at the end we concluded that sigma theta is equal to f of theta phi. So this is your what? So cross section, scattering cross section is a square of scattering amplitude. Right? This is, we have proved it here. Scattering cross section is equal to the square of scattering amplitude. Okay. This is a very important formula. I hope you understood this question. We'll slowly go into this chapter because this is not a hard chapter. It's easy, but we just should not just avoid the basic part and directly go to the questions. It should go in such a way that you should be able to answer all the questions you're asked in an interview. After doing 3-4 derivations, you will find it easy to solve these questions. The next question or derivation type I will do this kind of a derivation type. Okay. So be patient. This will be number 2. Question is in the partial wave analysis. In the partial wave analysis of scattering, partial wave analysis of scattering, the scattering amplitude f of theta is equal to 1 by k summation L0 to infinity 12 plus 1 exponential I delta L PL cos theta sin delta L. Okay. where k square is what? K square is 2 mu e by h cut square. Here mu is your reduced mass. Okay? And this is the expression for scattering amplitude, right? F of theta is from 1 by k summation L 0 to infinity 12 plus 1 exponential I delta L PL cos theta sigma sin delta L. Don't worry, you will easily remember it after a bit of practice. Obtain an expression. So you have to obtain an expression for the total cross section sigma. For the total cross section sigma, okay, and also show that also you have to show that sigma is equal to 4 pi by k. Sigma is equal to 4 pi by k. Okay. Imaginary part of f of 0. It's a very tricky question. Imagine if uh, this is imaginary part of scattering amplitude f of theta at theta is equal to 0. Okay, you can write that. Here, I am f of 0 is imaginary part, imaginary part of scattering amplitude, imaginary part of scattering amplitude f of theta at theta is equal to 0. Okay. So this is the question. We are given scattering amplitude f of theta. We have to find an expression for total cross section. We know in the previous question that total scattering cross section is equal to scattering amplitude square. That means sigma theta is equal to actually f of theta phi whole square, isn't it? So from here we can do it, but there is a trick part here. The thing is, this is given as a summation form. We just cannot take it as a square. So we have to kind of expand it a bit. So see how I solve it. So please first write the question. This PL cos theta is what? This is your legendary polynomial. Okay. So a lot of things are used here. The things that we are studying in mathematical physics. I hope you remember legendary polynomials, their values. Alright, let's start solving this question. First of all, sigma theta we know is what? F of theta whole square, f of theta phi, whatever, same thing, whole square. So I can write one thing here. Let me write the whole expression and square it first. Then after that I will do it. So 1 by k square, because k is there, 1 by k square. Sigma L to 0 to infinity 12 plus 1 PL cos theta exponential I delta L sine what? Sine delta L, I think. Yes, sine delta L and the whole square of it. Okay, whole square. So I have to put. Uh, okay, what will I do here? Mm, see one thing. Uh, see, sigma can be written as integration of sigma theta d omega. Okay, this is another formula where d omega we know d omega is what? Sine theta d theta d phi. Alright, so I can write it here. Sigma theta sine theta d theta d phi. Sigma theta sine theta d theta and d phi. The integration 0 to pi for theta, 0 to 2 pi for phi. Alright, so I can integrate d phi, so it will be 2 pi 0 to pi integration, because there is no phi term here, so I just integrated d phi 0 to 2 pi. So sine theta d theta. Alright, yeah. Okay, what's next? Okay, see here, this is your sigma theta, right? sigma theta. So let's do one thing. Let's put the value of sigma theta. Okay, let's put the value of sigma theta. That is this one. Okay, let's put it, and you can see this is a square here. So let me do one thing. Okay, let's put it first then also. 2 pi by k square 0 to pi. So the value of sigma theta, that is integration, sorry, summation L 0 to infinity 12 plus 1 PL cos theta. Why I'm doing this is, by doing all this you will get an approach to solve questions. Okay, it may not come in exam, but you will certainly develop an approach, solve more questions. Sine delta L square, and there is this sine theta d theta here, sine theta d theta. Okay, so what can I do here? See, this is a square, so I can multiply it twice, right? So see, so 2 pi by k square integration 0 to pi. So I will multiply it twice, 0 L to infinity 12 plus 1 PL cos theta. See very carefully, cos theta exponential I delta L sine delta L. Okay, and again I will multiply it with itself, summation L 0 to infinity 12 plus 1 PL cos theta exponential I delta L sine delta L. Okay, and sine theta d theta. Yeah. Okay, now see, there is a summation L 0 to infinity, so I can change it to L dash and everything will become L dash. It will be the same thing, isn't it? If I change this thing of a summation, everything will change, and it is the same, exactly the same thing. So what I do is L dash, L dash, L dash, L dash, L dash. It's the same thing. Okay, so there is nothing to worry about. Okay, why I did it? Because there is this legendary polynomial. There are two legendary polynomials inside, so I have to kind of do something about it. Okay, because we know for legendary polynomials, for legendary polynomials, if you remember the integration formula, that is the orthogonality condition, orthogonality relation. If you remember, what was that? Integration minus 1 to 1. Okay, PLX and PMX dx is equal to what? 2 by 12 plus 1 and delta LM. Okay, what is delta LM? Delta LM is 0 when L is not equal to M, and it's 1 when L is equal to M. So when these two are equal, I will get some value here, but when these are not equal, I will get this value as 0. Okay, if you remember, this is the orthogonality condition in legendary polynomials. Okay, yeah, right. So let's move to the next. Uh, okay, so what will happen here is, okay, so let's do one thing here. Okay. See here PLX, PMX. So let's do one thing. Let's change this cos theta into X. Okay. So if I do that, so I will put substitute. Actually, I will substitute cos theta is equal to X. So what will I get? Minus sine theta d theta as dx, right? Yeah. And the limits will also be changed. All right. Okay. So limits will also change, and this will become PLX. This will PL dash SX. And there is one thing, they this L should be equal to L dash. Otherwise, this whole integration will become zero and there will be no meaning. So L should be equal to L dash, and what will I get? I will get this 2 divided by 12 plus 1 delta Lm whatever. Okay. So after expanding all of this, actually, you will get a formula. I will directly write it down instead of just going through it. Sigma is equal to 4 pi by k square. Okay, summation L is equal to 0 to infinity 12 plus 1. Okay, sine square delta L. So this is the final expression I will get after solving all of that. I will not get into that. I will take a lot of time. So sigma is equal to 4 pi by k square summation L is equal to 0 to infinity 12 plus 1 sine square delta L. So this will be the expression for scattering cross section. Okay, this is the expression for scattering cross section. All right. Yeah. Okay. All right. Suppose, okay, what is asked in the question? So you have to, I got the expression, obtain an expression for total cross section sigma in terms of this. So I have to find this f of 0. Okay, let's put theta is equal to 0 and let's check what happens. So if I put theta is equal to 0, okay, okay, theta is equal to 0 means PL cos theta is the expression. So if theta is equal to 0, then it becomes PL cos 0, that is 1. PL1 is actually 1. Okay, so the scattering amplitude becomes what? Scattering amplitude will become scattering amplitude f of 0 will be what? What will be f of 0? 1 by k summation L is equal to 0 to infinity. Okay, 12 plus 1. See, PL cos PL1. This is the expression. So this term will become 1 because theta is 0. So PL1 is 1. So only this and this term will remain. So exponential, okay, what is it? What will let exponential I delta L sine delta L. Alright, this will let sine, oh yeah, sine delta. Okay, so yeah. So see, if I, okay, we are asked what? We are asked to express it in terms of imaginary part of f of 0. Okay, imaginary part. Okay, how will I get the imaginary part? If I expand this term, exponential I k, exponential I delta L 0 to infinity 12 plus 1. Exponential e to the power I theta is what? Cos theta plus I sin theta, right? So I will expand it here. I delta, I will get cos delta L plus I sin delta L, correct? Okay. So now I will expand it again. So 1 by k summation L is equal to 0 to infinity 12 plus 1. Okay. Cos delta L into sin delta L. Yeah. Plus 1 by k in summation L 0 to infinity 12 plus 1. Okay, this into this I into sine square delta L. Okay, so if you see, we need the imaginary term. So imaginary term is what? This one is the imaginary term, right? This one is the imaginary term. So I will do what? I will only write that term. So imaginary f of 0 will be what? So imaginary f of 0 is what? 1 by k. As I have written it imaginary, don't have to write I again, okay? 0 to infinity 12 plus 1 sine square delta L. Okay, yeah, sine square delta L. Okay, so if you check, this is what this expression is, isn't it, in sigma? So I can just put it here, imaginary f of 0. See, this and this are matching. So I will directly put it there. Okay, and 1 by k is there, and there, what is there? 4 by k square. So I will write it as sigma is equal to 4 pi by k imaginary f of 0. Okay, because there is 1 by k already here and there was 4 pi by k square there. So I think you understood that. So this is the proof. Okay, so this is proved. Whatever we started, we proved it. Okay, so this is actually called this equation is actually called the optical theorem. So remember it. You may be asked this one in interviews. You won't get it in exam, but you will be asked this in interviews. So it's very important. So yeah, this is the optical theorem. I hope you understood. Let's do one more question. Again, this is another derivation type. It will be. Why I'm doing this is like to get a basic approach towards solving this type of questions. If suppose the question comes long, so what will you do? You just cannot put the formula and get it. You have to expand it. You have to kind of go a bit deep into it. That's why we're solving this way. Okay. So this is the another question. Right on. Consider. Just change the pen color. Consider the scattering of a particle. This is when I'm writing like this. This is scattering. Okay. It looks like scattering, but it's scattering. Particle having charge z dash e by an atomic by an atomic nucleus by an atomic nucleus of charge Ze. Okay, if the potential representing the interaction if the potential representing the interaction if the potential representing the interaction is the potential that is given, that is Vr is equal to minus z dash e square divided by r e to the power minus alpha r. Okay, where alpha is a parameter, where alpha is a parameter. So calculate the calculate the scattering amplitude. Okay, use this result to derive use this result to derive to derive Rutherford's scattering formula to derive Rutherford's scattering formula Rutherford's scattering formula for scattering by a for scattering by a pure Coulomb potential. Okay, this is again a big question. Consider the scattering of a particle having charge Z dash E by an atomic nucleus of charge Ze. If the potential represents the interaction, this calculate the scattering amplitude. This is okay. So let's solve it. It's a bit tricky question, but we will solve it anyway. See, the potential is given here. This is the potential. Don't get scared by the word potential. It's just your potential. If you remember that we have studied in electrostatics. Okay, it's just that there are extra terms here, so we don't need to worry about it. Okay, so the thing is, there is this thing called first Born approximation, if you have studied it in quantum mechanics. So first Born approximation, okay. So scattering amplitude is given by f theta is equal to, what is the formula? Is 2 z z e z dash e square mu by q h cut square integration 0 to infinity sine qr e to the power minus alpha r dr. Okay, so this is the expression. Actually, what is the formula? Actually, the formula is f theta is equal to 2 mu by qh cut square integration 0 to infinity vr, okay, r vr sine qr e to the power minus alpha r dr. So I've just put it and directly put it and written it here. Okay, if you see, if you put the potential now, see, sorry, minus is there also. So now let's put the potential. So VR, I should have written it first. Okay, anyway, minus 2 mu by q h cut square integration 0 to infinity. Okay, R into VR. What is VR given? Minus z dash e square minus z dash e square by R. Okay, e to the power minus alpha R. Alright. Okay, sorry. Yeah. Okay, sorry, this term is not there. My bad. Yeah, e to the minus alpha r. Then sine qr is there. Sine qr dr. Okay, so if you see, this rr will be cancelled out. Minus will go outside. Z dash e square are constants because they don't have any work here. So 2 mu z dash e square divided by q h cut square 0 to infinity. Okay, e to the power minus alpha r sine qr dr. So this is the expression I am getting for scattering amplitude f theta. All right. Yeah. All right. So now what I have to do? Okay, there is a direct formula for this integration. Okay, so I will just directly put it 2 mu z dash e square by q h cut square. All right. The formula for directly this one is like q divided by q square plus alpha square. Okay. Yeah. So I got it. So this is the expression. So if I just squeeze it a bit, see, q get cancelled out. So 2 mu z dash e square divided by h cut square q square plus alpha square. Okay, q square plus alpha square. Okay, what is q actually? Q is actually called momentum transfer in scattering. Okay, q is actually called momentum transfer, and the formula for q is what? 2k sine theta by 2. This is the expression for momentum transfer. All right. Yeah. Okay. So here q square plus alpha square. Okay. Here in momentum transfer, what happens is, remember, in momentum transfer, you have to study this chapter very thoroughly. Q is very very greater than alpha. Okay. So this alpha can be ignored here. So I will directly put the value of q square then. So q square plus alpha square, here alpha can be ignored, so it will become q square. And q square will be what? 4k square sine square theta by 2, because your q is what? Q is 2k sine theta by 2. So q square will be 4k square sine square theta by 2. So I will put it directly there in place of f of theta. So f of theta becomes what? 2 mu z dash e square divided by, what was the denominator? Q square plus alpha square. So that becomes q square, which is your this one. So 4k square sine square theta by 2. Alright. Now what is asked in the question? The question is asking me to get uses related to derive scattering formula for scattering. Okay. Scattering amplitude I got. Now I have to get scattering cross section. Okay. So scattering cross section is what? Sigma. Sigma is equal to what? F of theta square. That's it. So I will just get the square of it, 4 mu square z dash square e fourth divided by h fourth into 16 ks fourth sine fourth theta by 2. That's it. Okay. So this is the expression for what? So this get cancelled out. This gets 4. So this is the expression for your what? scattering cross section, and this is also called Rutherford's formula for Coulomb scattering. Okay, so this is not hard. As you can see, slowly we're going there. It's like we just have to find scattering amplitude first. The formula for scattering amplitude I have written here: minus 2 mu by qh cut square, 0 to infinity r v r sine square dy. You have to put the potential there. After putting the potential, you have to integrate it. Just remember the value of this integration, okay? And then you just have to put the value of f of theta square. That will be your sigma. Okay, so this is the way to solve it. All right. Yeah. So yeah, that will be it for this class. We'll be solving more questions from scattering in the upcoming sessions. Okay. So the thing is, the purpose of this videos will be to solve longer questions, because this type of questions come in exams. Okay, they don't ask you direct formulas anymore. Okay, you have to derive some part of it. You have to use all the concepts you have inside you. Otherwise, you won't be able to solve it. And also in interviews, they ask you like this. They want to ask you direct what is the integration of this. They will ask you how can you get me this final expression, okay, from this. So that is how interviews are done. Okay. So yeah. So that will be it. So see you in the next class. Thank you very much.